So this is an example question. Say a graph is given, a distance travel, the graph shows, or the graph below represent the distance traveled by a car plotted against the time. So distance traveled by the car plotted against the time, that as you can see here. If the question is explain the motion from A to B. So what is happening from A to B? You can see from position A to position B. What is happening? Because as we discussed, there are four possibilities for a distance time graph. It might be a horizontal line, it might be a straight line, it might be a line with increasing angle, or it might be a line with decreasing angle. Just for your assistance, I will sketch a simple graph. Like it can be a straight line through the origin, it can be an increasing angle, it can be a decreasing angle. And what are the explanation? This means the object is at rest, this means it's constant speed, this shows it is accelerating, and this shows it is decelerating. So from A to B, which position it, which shape it matches with from A to B. And I want participation from everyone, because your participation shows your understanding. This is a way by which I can assess that you are understanding a topic. So from A to B, as you can see, the slope is increasing. So you can say that this object is accelerating, or acceleration is there from A to B. That's right. Good. What is happening from B to C? From B to C, the part B to C, it appears as a straight line. So as it appears as a straight line, so you can say that it is moving with a constant speed. And what is happening from C to D? So when you check the region C to D, so from C to D, you can clearly see it matches that it is decelerating. Or speed is decreasing, you can say. And what is happening from D to E? It's a horizontal line. So from position D to position E, it's a horizontal line, or you can say the car stops, or car is not moving from D to, or car is stationary. So this is the explanation of the motion for this car, which is changing its motion. First it was accelerating or speeding up, then it traveled with a constant speed, then it is decelerating or slowing down, and eventually the car stops. Is it clear? This graph, distance and time, which explain the motion of a car. Then next part is about some calculations, what we can do. Example, describe the motion of a car from A to E, that we already discussed, so we don't have to answer that again. How far the car travel at the end of 30 seconds. So after 30 seconds, what is the distance traveled by this car? So how you can work out the distance traveled by the car after 30 seconds? So this is a 30-second mark. This is a 30-second mark. So to know the distance traveled by the car in 30 seconds, you will draw a line from 30 seconds on the graph and find the distance traveled. So after 30 seconds, what is the distance traveled by this car? It traveled 60 meters. Is it clear? How we work out the distance traveled by the car after 30 seconds. So we just draw a line from 30 seconds and find out the distance from y-axis to identify the distance traveled in 30 seconds. The next part, calculate the speed of the car between B and C. So we need a distance, we need a speed from B to C. So how we can work out the speed from position B to position C? This is position B or point B. This one is point B and this is point C. So we have to first calculate the distance traveled from B to C. So at point B, it is 10-meter mark. Like at point B, it was at 10 meters. And at point C, it is at 50-meter mark. So what is the distance traveled from B to C? When the car is at point B, it covered 10 meters. When the car is at point C, it covered 50 meters. So what is the distance travel? First, what is the distance traveled by the car? So the distance is equals to 40 meters. Is it clear till now? The distance traveled by this car? Because at point B, we don't need the total speed, we need the speed from B to C. So we should know the distance traveled from B to C. So at point B, it was at 10-meter mark, and at point C, it is at 50-meter mark. So from B to C, it covered 40 meters. And what about the time interval? So when you check that at point B, what is the time interval? Each box is representing 1, 2, 3, 4, 5, and 6. So this is 6 seconds. And at point C, it is at 20 seconds. So what is the time interval from B to C? From 6 seconds to 20 seconds. So the time interval is equals to 14 seconds. So it should be 40 divided by 14, and 40 divided by 14 will give us 2.85 meter per second. When you write your answer, it should be in three significant figures. That's why I'm saying 2.85, not 2.8. So whenever you write your answer, it should be in three significant figures. So 2.85 or 2.86 I can say, because it is written 2.857, so I can say 2.86. Is it clear? The speed of this car from B to position C. How I got 40 meters? When you check object at position, because we need speed from B to C. When car is at point B, it already covered 10 meters. When car is at point C, it already covered 50 meters. So what is the distance covered by the car from B to C? So the distance covered, it will be 50 minus 10, that's equal to 40 meters. So from the starting point, like if this was a starting point, there is point B and then point C is there. So from the starting point Point B is 10 meter apart from the starting point. And from the starting point, point C is 50 meter apart. So what is the distance from B to C? The distance from B to C, that is 50 minus 10, that's equal to 40. Is it clear, Lamia? Is it clear to everyone that how we got the speed? Then, so we got the speed from B to C that was coming out as 2.85 or 2.86 meter per second. Then what is the distance traveled from A to D? Using a graph, what is the distance traveled from A to D? This is point A, the starting point, and this is point D. Yeah, what's the distance traveled by this object from A to D? At A it is 0 mark, and at D it is 60 meter mark. So what is the distance traveled from A to D? So that's equal to 60. That's right, Abdullah Sarfraz. So the distance traveled from A to D is also 60. Then what is the average speed from A to D? So to get the average speed is the distance divided by time. So distance travel, average speed from A to D. So the total distance from A to D is 60 meter, and the total time it took, because A is at 0 and D is at 30, so that is equals to 30. So 60 divided by 30, that's equal to 2 meter per second. The average speed will be equal to 2 meter per second for this object. So this was 2.86 meter per second. This distance was 60 meter, and average speed is coming out as 2 meter per second. You think it is 29 at D? Let me check. Yeah, point D is at 29. That's right. So it will be 30 divided by 60 divided by 29, Abdullah. So 60 divided by 29, which will come out as 2.06. That's right. So we'll take 2.06 meter per second. Then another question related to this topic. So if we have a distance time graph, and it is a straight line, and this is 10, 20, 30, and 40. Distance is in meter and time is in second. The first question is explain the motion of the object. Yeah, explain motion of an object means what is happening to object, what object, how the object is moving, accelerating, decelerating, or at rest, or moving with a constant speed. So what is the motion of this object? This object is moving with a constant speed, that's right. Then find the speed, find the average speed of object after 3 seconds. So if you want an average speed is the total distance divided by total time. So this is after 3 seconds, this object covered the distance of 30 meters. So the average speed, because the average speed is the total distance divided by total time. So total distance travel is 30, and the total time it took, that is equals to 3. So 30 divided by 3, that's equal to 10 meter per second. Is it clear? The average speed of the object, because the average speed is the total distance over total time. So total distance travel is equals to 30, and the total time interval, the time it took, that's equal to 3 seconds. So 30 divided by 3, that's equal to 10 meter per second. And you may have a graph with different sections, and you have to explain the motion of an object. Like we have a distance time graph, distance is on y-axis and time is on x-axis. And the sections are, this one is A, B, C, D, and E. Now, the first question, explain the motion from A to B. So what is happening from A to B? If in exam you simply write constant, then constant is not the full term, it should be constant speed. So you should mention it is moving with a constant speed, or uniform speed you can say. What is happening from B to C? What is happening from position B to position C? So object is stationary or at rest, or object stop. What is happening from C to D? C to D. Is it accelerating or decelerating? So from C to D, the angle is increasing. So if angle is increasing, we use the term accelerating. And from D to E, what is happening? Again, it is a constant speed. So simply, if you write constant, that is not a full answer. You should mention it is constant speed. That is part A. Then part B is compare the speed A to B or D to E. So which value of the speed is higher? From A to B it's higher, or from from D to E it is higher? So from A to B it is higher. Why A to B is higher? Because the angle what it's making with a horizontal line or x-axis, that angle is much higher as compared to the line D to E. It's making a smaller angle. So simply by using a angle or a gradient, and how you explain this answer, you can mention A to B is higher speed because greater gradient or angle, or you can also say slope. So these are the terms which used to explain the comparison. This is way we compare, that we mention the term speed by using a gradient, angle, or a slope. Is it clear to everyone? So this is about distance time graph. Then the second type of a graph is a speed time graph, but that we'll discuss tomorrow. Now we'll do some questions related to distance time graph. So I want only the answer for C and D. What is happening in C, graph C? Not about A and B, because we did not discuss speed time graphs. Speed time graphs we'll discuss tomorrow, because I want you to take time and go through distance time graph first, and then we'll compare speed time graphs. What is happening from C in graph C? Is it accelerating or decelerating? The object. Distance time graph, accelerating or decelerating? I'm talking about C. Yeah, that's right, Basra. That's decelerating. Why decelerating? Because you can see the angle is decreasing. If it was accelerating, then what should be the graph? It should go steeper, like this. This is for accelerating, and C is for decelerating. So here speed is decreasing, or you will mention decelerating. What is happening from for graph D? This graph D. So it is moving with a constant speed. Again, I repeat, in exam, not don't say only constant. You should mention a term constant speed. Okay. Figure 1.1 shows axes used to plot a distance time graph. On figure 1.1, draw a graph of an object that is moving with a constant speed and label that as A. So I want everyone to use screen annotation and draw a graph for A. First only for A. And label that as A. Label that as A means you should write letter A for that. That's right. It will be a straight line and moving with a decreasing speed. Decreasing speed means decelerating. The term decreasing speed means deceleration. So how you represent a deceleration? Not from the same point, Heather, from the it's separate graph. Like one of the graph is already done. Yeah, that's right. So the first one for a distance time graph, we label that as A, that is the constant speed. And the second one, it's decelerating, so we can label that as B. Thank you for your participation. Okay, another question related to distance time graph. Describe the motion of a cyclist from 0 second to 15 second. So what is happening from 0 second to 15 seconds? From 0 to 15 second, what is happening? It's a distance time graph. So it is accelerating. Why it is accelerating? Because the angle is increasing, so it is accelerating. When angle increase, we call acceleration. From 15 seconds to 30 seconds. So from 15 to 30, what is happening? It's a constant speed, that's right. And from 30 seconds to 40 seconds, it is decelerating, that's correct. So first part it was accelerating. The second part it was constant speed, and then it is decelerating. So we can say it is decelerating. Now, the second part, calculate for 40 seconds the average speed. So we have to calculate the average speed for 40 seconds. So what is the total distance travel for 40 seconds? That's 300. And what is the total time? As I already mentioned, that is 40. So 300 divided by 40, that will come out as, so 300 divided by 40, this will be equal to 7.5 meter per second. Okay. Now the next part, they ask what is the maximum speed. So as we know, this object is continuously changing the speed for from 0 to 15 second. It was accelerating. then it was traveling at a constant speed from 15 to 30, and then it was moving with a, then it was decelerating. So which part it will have the maximum speed, A, B or C? Which part it will have the maximum speed or highest speed? Which region? Which region it will have the highest speed? Speed, I told you the angle, using the angle you can identify that which region it will have the highest speed. So which region is having the highest angle with x-axis? A, B or C? So when you draw the x-axis, the horizontal line, this is for region C, for B and for A. Which region it is having the highest angle? So for region B, it is having the highest angle. So it will have the maximum speed in this region. So basically we have to find a speed from 15 second to 30 second, and that will give us the maximum speed. And how we can work out the maximum speed in this region? So we have 15 second and 30 seconds, the interval, because it is continuously changing the speed. First it was accelerating, then moving with a constant speed, and then decrease the speed. So time interval is 15 here, and the distance traveled, so the distance traveled at time 15 and the distance traveled at time 30. So this is 250, this one is 50, 60 and 70, and the time interval, this is 15 and 30. So the time interval from 15 to 30, that's equal to 15 seconds, and the distance travel, that is 70 and 250, so 250 minus 70, that's equal to 180. So this will be 180. So if we need the speed, maximum speed, that will be 180 divided by time interval, which is 15, equal to 12 meter per second. That is the answer for the maximum speed. Is it clear, this part? That how we worked out the maximum speed? First we work out the region where it will have the maximum speed, because the point, the region where it is steeper or greater slope, that region it will have the maximum speed, and that region is from 15 second to 30 second. So we have to find basically a speed from 15 second to 30 seconds. So sometimes they change a question, they change the wording, but like if they directly say calculate the speed from 15 to 30 seconds, you can simply work out. But this time what they did, they make a question a bit tricky just by telling calculate the maximum speed. So to work out the maximum speed, first you have to work out the region in which it will have the maximum speed. And how you'll work out the region in which it will have a maximum speed? By looking at the angle or the gradient. So in this region, it will have the maximum gradient. That's why it will have the maximum speed. Is it clear? The concept of distance time graph and some calculations we did related to distance time graph. Any question related to the class today? So I'll end the session and share this recording with you.